It started with a single jolt off Barbados, a clean rupture, moderate, unremarkable on paper. But within hours, something strange happened. Tremors erupted across the eastern Caribbean, hundreds of kilometers away, in zones that should not have reacted so quickly. It looked like coincidence. It did not feel like coincidence, not to the people who watch this arc, because here nothing is isolated. The Caribbean is a chain of locked plates, fractured blocks, deep faults waiting for a reason to move. Any reason. What if that first quake was the reason? What if one rupture did not end the story? What if it started a sequence, a cascade, one event pushing the next, a chain reaction traveling through the Earth's skeleton? If that is true, we are not looking at an earthquake swarm, we are witnessing a system waking up. Let me show you what happened. The quake was small, brief, clean, a magnitude 5.0, the kind you catalog, analyze, and move on from. But beneath these islands, nothing is ever that simple. Within 3 hours, seismic stations recorded unusual tremors. In Martinique, in Dominica, in Guadeloupe, too clustered to ignore, too remote to relate directly. You do not see this pattern unless something deeper is happening. The Caribbean has a unique structure. The Caribbean plate pushes eastward. The Atlantic plate dives beneath it. Between them sits a scatter of smaller plates. Think of a jigsaw puzzle. Irregular pieces, tight spaces. Every shift forces another. Most people imagine plates as giant slabs. In the Eastern Caribbean, it is more complicated. The arc drifts millimeters per year. Stacked blocks grind past each other. Fault lines cross the Lesser Antilles like scars. Here is the problem. When one patch slips, it reduces stress locally, but it increases stress elsewhere. Think of it this way. A slipping fault relieves pressure in one room, but it pushes that pressure into the hallway. Scientists call this stress transfer, and in the Caribbean it matters a lot. One seismologist explains it simply. Indonesia, Japan, Turkey, Italy. We have seen earthquakes trigger others. And in the Caribbean, it is absolutely possible. Hours after the Barbados rupture, the arc responded. Fast, too fast. Seismic waveforms flashed across the regional map, pulses spreading outward like drops hitting water. Was this randomness or the start of a chain? That is the question. That is what keeps scientists watching. Because if this is a cascade, we need to understand it. We need to see it coming. We need to prepare. The first quake happened. The arc responded. Now we wait to see what happens next. The swarm intensified. Let me show you the first 24 hours. Barbados, magnitude 5.0. St. Lucia, micro tremors. Martinique, deeper long period event. Guadeloupe, cluster of 3, each with a timestamp, each in a different location. Not enough to panic, enough to notice. Scientists call these regions stress shadows. Let me explain. Stress shadows are regions of increased strain after a rupture. Sometimes they overlap, rarely they synchronize. Think of it like a wave. The Barbados quake relieved stress in one spot. But along the arc, certain blocks tightened, like muscles bracing. When 2 or more stress shadows overlap, something dangerous can happen. Localized faults can wake up simultaneously. One geophysicist explains, that is when we get cascades, a sequence, one quake making the next one easier. The Eastern Caribbean has many fault zones, the Tiburon Ridge, the Oriente Fault, the Anegada Passage, back arc spreading centers. Each is reactive, each is sensitive to stress redistribution. Think of dominoes. You push one, 4 others move. That is how these faults behave. They share strain, they react together. Data started revealing a pattern. Depths were aligning, timing was forming clusters, magnitudes were stepping up, not down. This hinted at multi-fault triggering, not random quakes. It was subtle, but unmistakable. A rhythm was forming. You do not want to see steps like this. Steps suggest buildup, alignment, momentum. Let me paint the picture clearly. Imagine a line of blocks. Each block touches the next one. When one block shifts, it bumps the next. That block bumps another. The pressure travels, not instantly, but steadily. In the Caribbean, these blocks are microplates, small pieces of crust between the big plates. They grind, they pivot, they lock. When one moves, the others feel it. The Barbados quake moved its block. That movement pushed on St. Lucia's block. St. Lucia's block pushed on Dominica's. Dominica's pushed on Guadalupe's. A chain of pressure, a cascade of stress. Scientists watched this unfold in real time. They saw the pattern emerge. They saw the alignment. They saw the danger, because here is the truth. The swarm was not fading. It was sharpening, getting clearer, getting stronger, getting more organized. And organized seismic activity is dangerous, very dangerous. It means the system is not random. It means forces are converging. It means something bigger may be building. The arc was responding to the first quake, block by block, fault by fault, hour by hour, and nobody knew where it would stop, or if it would stop at all. Let me pull back the curtain. There is a theory in tectonics. Scientists call it the domino theory. Multi-fault, multi-stage ruptures across adjoining blocks. Think of strings pulling on each other. Tug on one, four move. That is how locked faults share strain. This has happened before. Let me show you. Turkey, 1999. Two massive quakes, 87 days apart. Same fault system. The first quake triggered the second. Stress transfer, Japan 2011. The Tohoku megathrust caused widespread aftershocks across distant segments miles and miles apart, all connected by stress, Puerto Rico 2020. A swarm escalated for months. A slow approach, then a sudden magnitude 6.4. These cascades are rare, but they happen, and when they do not look like random tremors. They look like what we are seeing now. Scientists have created a model, a prediction of how strain may migrate in the Eastern Caribbean, Barbados to St. Lucia segment, St. Lucia to Dominica microplates, Dominica to Guadeloupe Ridge system, Guadeloupe to Anegada Passage. This is not a straight line, it is a branching path. One rupture opens possibilities, not certainties. Possibilities. Possibilities that did not exist before. There is more evidence. Hydroacoustic buoys in the deep ocean detect subtle pressure anomalies, signs of shifting seafloor, blue pulses of pressure moving across the trench. The seafloor is responding, not just the surface, the entire system. Experts weigh in carefully. A cascade is possible. We have seen this before. And if experts say it is possible, the question becomes clear. How far can it go? The mechanism is understood now. Stress transfer between microplates, overlapping stress shadows, faults waking up in sequence, but understanding the mechanism is not enough. We need to know what the sequence looks like when it unfolds. We need to see the steps. Here is what scientists know. A cascade does not require large quakes. It requires stress compatibility. A fault will move only when conditions align. The Barbados quake may have nudged faults that were already close, already whispering, already counting down in silence. It may have awakened segments that were almost ready. One quake does not cause another, but it can prepare it, prime it, tip it closer. Think of a row of books leaning against each other. Each book is stable, but barely. Push one book, it falls into the next. That book falls into the next. The row collapses, not because the first book was special, but because all the books were already leaning, already unstable, already ready to fall. The faults in the Caribbean are like those books, leaning, locked, ready. The Barbados quake was the first push. Now we watch to see which books fall next. Scientists monitor every tremor, every small shift, every pressure change. They look for patterns, they look for alignment, they look for the next step in the sequence, because if this is a cascade, it has only just begun, and the question remains, where does it end? What triggers the next rupture? Not magnitude, not proximity, stress compatibility. A fault will move only when conditions align. The Barbados quake may have nudged faults that were already whispering. It may have awakened segments counting down in silence. Let me show you how this works. Imagine a simulation, a multi-step map of pressure. First push from Barbados. Stress rolls into St. Lucia segment. A locked patch near Dominica destabilizes. Pressure rises along Guadeloupe's outer arc. Four-arc compression near Antigua intensifies. One quake does not cause another, but it can prepare it, prime it, tip it closer. This is not theory. This is observation. This is pattern recognition. Communities in the Caribbean remember past sequences. A fisherman recalls tremors before the 2007 Martinique quake, weeks of small shakes, then a big one. A teacher describes the 2020 Puerto Rico swarm, weeks of anxiety, not knowing if it would get worse. People living on fragile islands face unique fears, uncertainty, not knowing whether they are watching a harmless swarm or the opening act of a cascading chain. This is the emotional weight, the psychological burden. Every tremor raises the question, is this the big one? Is this the next step? Should we leave? Should we stay? This is not prophecy. This is not prediction. This is probability, shifting beneath us in real time. Scientists cannot tell you when the next quake will happen. They cannot give you a date, but they can read the signs, and the signs are clear. The arc is reacting. Stress is migrating. Faults are responding. The system is in motion. Think about what this means. Every rupture redistributes the load. Every shift changes the odds. Some faults relax, others tighten. The pattern evolves. The risk moves. What was safe yesterday may not be safe today. What was locked yesterday may be ready today. This is the nature of cascades. They are slow. They give clues. They reveal the architecture of hidden faults. They expose vulnerabilities. They show us where the weak points are. But they also create fear, because slow does not mean harmless. Slow means drawn out, uncertain, prolonged. People in the Caribbean live with this reality. They watch the news, they feel the tremors, they wonder, and they wait. What happens next depends on the blocks that have not moved yet, the locked segments, the silent faults, the patches building pressure in darkness. Scientists monitor them constantly. Seismometers record every vibration. GPS stations measure every millimeter of movement. Buoys detect pressure changes in the ocean. Satellites track ground deformation. The data flows in continuously, and with every new tremor, scientists ask the same question. Is this part of the cascade, or is this something separate? The answer is not always clear. Seismology is not an exact science. The Earth does not follow scripts. It surprises us. It defies expectations. It moves in ways we cannot always predict. But one thing is certain. The Caribbean arc is adjusting, rebalancing. Every rupture redistributes the load and reshapes the odds. We are watching a system in transition, not catastrophic, not apocalyptic, but sensitive, reactive, tightly coupled, and that makes it dangerous. Let me tell you the present truth. The Caribbean is entering an unstable phase, not catastrophic, not apocalyptic, but sensitive, reactive, tightly coupled. The arc is adjusting, rebalancing. Every rupture redistributes the load and reshapes the odds. There are two possible futures. Let me show you both. Best case scenario, the swarm disperses, stress dissolves into harmless microtremors, no major event follows. The system stabilizes, the cascade ends before it truly begins. This can happen. It has happened before. Many swarms fade into nothing. They release pressure slowly, gently, without disaster. But there is another possibility. Worst case scenario, one or more faults rupture within months. Not because the Barbados quake caused them, but because it joined a system already leaning toward failure, a system already on the edge, already ready to break. The quake was the nudge, not the cause, the nudge. And sometimes a nudge is all it takes. Cascades teach us lessons, important lessons. They are slow. They give clues. They reveal the architecture of hidden faults. They expose vulnerabilities and blind spots. They show us what we did not know before. They force us to pay attention. They demand preparedness, not panic, not sensationalism, but real awareness, real vigilance, real respect for the forces beneath our feet. The Caribbean has always been seismically active, but activity is not the same as instability. Activity is normal. Instability is dangerous. And right now, the arc is showing signs of instability. Not everywhere, not all at once, but in specific segments, in specific zones, in places where stress has accumulated, where faults have locked, where pressure has built. These are the danger zones, the places to watch, the places that might move next. If this is the first domino, the next moves are already being written underground, quietly, invisibly, but not randomly. The Earth does not act randomly. It follows rules. Physical laws, stress and strain, pressure and release. We may not see the rules clearly, we may not predict the timing perfectly, but the rules exist and they are operating right now, beneath the Caribbean, beneath the islands, beneath the people who live there. Scientists continue monitoring every tremor, every shift, every signal. They look for patterns, they build models, they test predictions, they try to understand. Because understanding is the first step to preparedness, and preparedness saves lives. Communities in the Caribbean cannot stop earthquakes, but they can prepare for them. They can build stronger buildings. They can create evacuation plans. They can educate citizens. They can train emergency responders. They can do all of this. And they are doing it because they know the truth. The arc is restless. The faults are active. The system is in motion. One quake began the story. The earth will decide how it ends. We cannot control the magma. We cannot stop the pressure. We cannot lock the faults. All we can do is watch and prepare and respond. The Barbados quake was magnitude 5.0, small by global standards. But in the Caribbean, no quake is truly isolated. Every rupture matters. Every shift counts. Every tremor tells a story, and this story is still being written. The arc breathes, it moves, it adjusts, it searches for balance. Whether it finds that balance peacefully or violently depends on forces beyond our control, forces miles beneath the surface, forces older than humanity, forces that do not care about cities or people or plans. They simply are. And they will do what they have always done: move, shift, break, release. Our job is not to stop them. Our job is to understand them, to respect them, to prepare for them, because the earth is speaking. Clearly, urgently, through every tremor, through every shift, through every cascade that begins with a single jolt. One quake began this story. The earth will decide how it ends.